break.
Let me look.
No.
We ended with...
The reason this is taking
Yes,
a lot
we did.
longer is because I have to go back and do an easy example and then a hard example, one after the other, because I have kids coming back at random times from illness, right?
We finished.
Good.
Yeah, we did.
Or did finish it, we proved what it wanted us to prove.
Yeah. Sure. Sydney, I'm gonna...
I thought you guys did.
Why
All right,
is
I've got problem 7 and 8 for those that need it. If you need the whole packet because you've been absent a ton, I have the whole packet too. I'm sorry that I've had to be adding on more and more, but like I said, I have had easy problems in, so
What
when you come back, I
problem
can do a quick
are you doing?
example.
What problem are we doing?
7 and 8, number 8.
We already did 7.
Yes, but you have the page that 7 and 8 is on. Do you guys have number 7 and number 8?
I have no clue. I think so.
I bet you guys.
Yes, we do, because you gave it to me
Can I ask a
yesterday.
question
Did you?
real quick?
Yes, very good.
Can I do a late celebration for 2 seconds?
Yes,
We
go.
did do 7.
I need to sign.
I'm going to.
Acquitted, acquitted, acquitted. How can I
saw it.
There wasn't even a trial.
I'm just like, the signs in here, I gotta do something with it. It's gonna get dusty, Mr. Mayor.
Just? That's my class.
But yes, I have 7 and 8. And how are you today?
Oh,
I'm feeling mathematician-like.
yeah, that's good.
Hey, that's my paper
Chances here.
airplane, you dig.
First half, that's a ball.
What?
Katie, you're not going to get it.
What?
Landez says you're allowed to be late. All
Why?
right, here we go. It's time. I'm starting right now. Carpenter, let's go.
It's early.
Wow.
Classes at freaking start.
It is time.
You don't get it.
All right, here we go. So, today we're going to prove feedback.
Did you say prove P-tag?
Yep, we're going to prove it.
Why? It's already a thing. Why?
Because we need examples with proving triangles similar, and this is one that does it.
Where do I sit?
Oh, never mind. I got it now.
So that's what we're going to do.
You need
So-
2 planes.
We've used PTAG before in the past, last semester, to prove distance formula, right? We assumed what? Number 8. You have it? If you don't, I can give it to you.
We still haven't done number 5 either.
I know.
Mr. Mac, when are you going to put the grades in?
This week.
Isn't today midterms?
Yeah, but it doesn't matter. It's progress reports. The progress reports will be printed out until next week.
Progress report is a day. 1, 2, 3.
But it won't be printed out until next week anyway, so who cares?
Oh my god. I need to get my
You
stuff
say you're
together.
putting grades in this weekend, which means I'll have an F in this
Yes.
class.
The reason I'm behind on grades, just so we are clear, is because everybody else turned in late homework, and I have decided out of the goodness of my heart to actually grade it instead of just not, which was our agreement at the beginning of the semester, right? And that has put me behind from grading a lot of other things. Also, a lot of you guys bombed your recent quiz 2 quizzes ago, which you should not have. The one with side angle side and side side, yeah, that's embarrassing. But you bombed it, and then you want to retake it, which means I've got to grade those too. So out of the goodness of my heart, that is why those grades are
I
not
have a
good.
question really quick.
Yes.
Can I take my last
Are you ready to
class?
take it?
I'm ready.
Are you going to bomb it again? Because if you're going to bomb it
I've never
again.
bombed it. I haven't taken it.
Okay, great. But are you going to not bomb it? Because if you're going to not bomb it, I'll let you take it. But if you're going to bomb it, then why were we wasting each other's
I've been
time?
reviewing with you for 3 days, so.
And you're good to go?
I think I'm
You have
good.
not been reviewing with me, but you've been reviewing, right?
I've been reviewing with you in homeroom.
No, you have not.
I've been paying attention.
No, you have not.
Yes, I have.
No, you have not.
Okay, well, I'm ready to take it.
Awesome. So I'll give you the review guide, and if you can pass the review guide, I'll let you pass the quiz. That's what I'm
Matt,
going to do for
don't
other
do
people.
that to me. I don't have to retake
It's not me
it.
doing anything to you.
It's you making me do extra work.
No, it's not, because if you take it right now, then I have to grade it on my own, and when I grade it on my own, and it's a fail, it's gonna be a waste of my time. And as you can tell, lots of other people need my time. So stop wasting my time, jump through the hoops like everybody else does, especially since they're this high up the ground, and stop whining. What's your question?
Do you have, what's it called? What page?
8. Page 7, but number 8. I've got the whole, do you need the whole packet or just that? Okay. Alicia, do you have number 8?
I do.
Rad. Hi. You were gone a lot. Here's this for you. That's the whole thing we're on.
Yeah, you just
Buckle
sat
up.
through?
All right, here we go. So, again, because we have people showing up at random times, we have to add on easier problems to mix in. This one is sort of an easier problem, but also not. Again, where it's Friday. I kind of have to give a medium one out, okay? So, here's the deal. For those of you joining us for the first time, right, or need a refresher, we're proving triangles similar. So, Jenna, instead of proving triangles to be the same, which is congruency, right?
Yeah.
We're going to prove that they are similar, meaning that their angles are all the same, but their sides are related somehow. So, for instance, Jenna, this triangle, 3, 4, 5, is not the same as this triangle, right? Do we agree with that? Okay, but they are related. Notice that all of the sides are related by double. Does that make sense? Okay, so we would say that these are similar by side similarity. So the way we can prove similar, that's the symbol for similar, okay? It's like the equal sign with the right, but it's just a squiggle. The way we can prove that is that all 3 sides are similar, and so that's one of the things we have similar to regular SSS, right? Again, not that they're all the same, but that they're related by the same way. See how they're all double? If that was a 12 down here, 5 times 2 doesn't get us 12, so they wouldn't be similar, right? Just because 3 times 6 gets it and 4 times 8 is times 2, if we had 5 times 12, that would screw it all up and we'd be shot, right? So it wouldn't be good. So SAS is another one. Remember, for similar triangles, their angles are the same, but their sides are similar, right? So we're talking about 2 similar sides. So if I knew this, right? If I didn't have this information, but I knew that, okay? But I knew the angle between them was the same, that would be enough to say it as well. Does that make sense?
Yeah.
Okay. Lastly, we have angle, angle. We only need the 2 angles, because if we know 2 angles, we get the third for free. Does that make sense?
Yeah.
Right? So if I knew that I had 2 triangles that had 2 angles that were the same, then that would be enough to say the third. Right? Before we said they couldn't be congruent with angles, right? But similar, this is enough to get it done, okay? All right, cool. You know CCP?
Yeah.
Well, we have a CSP, corresponding similar parts, that we're going to use, but it's the same dumb crap, match up the letters. Okay? So here's what we're going to do, guys. It says angle C and angle D are 90. So angle C, 90 degrees. Angle D, 90 degrees as well. Yeah, Jenna, if you could, please.
I'm sorry.
Don't get
Put
sick.
a hand sanitizer under there.
How do you think I feel, all right?
Okay?
I'm actually
Mr. Mayor, you're gonna get sick. If she keeps coughing like
I
this.
just
Yeah.
want hand sanitizer.
So I've got it. Had it
We
since
should
the beginning of the
block
year.
Jenna's trachea.
I am fighting against germs.
You already got sick.
I did. I do the best I can. You guys are bags of germs.
Huh?
I haven't got sick.
This is true, knock on wood. All right, so here's what we're doing. We're going to prove PFAC. Now, I could have written this thing here, a squared plus b squared equals c squared. I could have written it as bc squared plus ac squared equals ab squared. I could have done that, but like that's a lot of letters and that's weird. So what I did is I called bc its length little a. You guys see Nacho Libre, right?
Yeah.
Little x, big x, right? It's talking about little hug, big hug, little piece.
The big guy.
Exactly. So we have little a and we got big A.
Muchos.
The big letters are the points of the triangle, right? The little letters represent the length of those sides. So I could say the length of BC is just BC, or I could say the length of BC is A. They're the same thing. We cool with that?
Wait, Mr. Man.
Yeah.
Right? Oh, never mind.
So our job is going to be to prove that the little triangle is similar to the medium triangle, and the medium triangle is similar to the big triangle, and this little triangle is similar to the big triangle as well. And then when we have them all similar, we're going to mess around with their parts, and we're going to get this, okay? So we're going to prove them all similar, use CSP, move stuff around and get that, okay? So here's another thing I got to talk to you about. Small triangle, medium triangle, big triangle, right? We'll go with large, okay? Small, medium, large. Okay, check it out. It is true that these are similar, right? Because they're doubled, right?
Yeah.
These are also similar because they're doubled. 6 to 12, 8 to 16, 10 to 20, right?
Wait, just. Oh, yeah.
Right? It is also true that small and large are similar because 3 times 4 is 12, 4 times 4 is 16, and 4 times 5 is 20, right? So these are double, these are double, but if you notice, are these double? No, they are similar, right?
Quadruple.
Because they're related by quadruple, but they're not all similar to each other. Does that make sense? In pairs, it's okay. Small and medium are double, medium and large are double, small and large are quadruple, so they're all similar, right? But I can't say small is similar to medium the same way that medium is similar to large. I can't do that because all three aren't the same thing, right? Small to large isn't the same. A lot of you guys would like to say, well, if small and medium are similar, right? If small and medium are similar, and I know that medium and large is similar.
Small would have to be similar to large.
Small must be similar to large by the transitive property, right? I'm touching the table's touching the pen, therefore I am touching the pen, right? But here's the deal. Transitive property only works with equal signs. And are we saying these are equal?
No.
No.
Similar.
And here's why it doesn't work. Because if I go small to medium, it's double. But if I go small to large, it's quadruple, right?
Yeah.
So I can't say all three are similar the same way, right? They're similar in different ways. It's the same difference. Okay? So what we're going to have to do is we're going to have to prove these two similar, then we're going to prove those two similar, and then we're going to prove small and large similar. Okay?
So you're going to do what you just said.
We're going to do all what we said, but we can't do it all at once. We have to do two at a time. Does that make sense?
Yeah.
Okay, cool. So here's what we're going to do. All they gave us is a right angle here and right angles there. That's all you need. Pythagorean theorem, all it says is, look, if you got a right triangle, you can do this, right? So they gave us a right triangle, and then they dropped a perpendicular so we'd have other triangles to talk about, right? If we only have one right triangle to talk about, what are you going to prove it congruent to? What are you going to prove it similar to? You have nothing, right? So what they did is said, I need some more triangles to get this done. So they know we can always let there be line and have it perpendicular. Where it intersects, I don't know, right? But there should be a point where it does, right? It's not going to be here, it's not going to be here, it's going to be there, right? So they drew that for us, and that's okay. So before this proof began, someone said, let there be line, and they made that perpendicular. Totally kosher. Yeah?
Is there a reason why you made the line, let there be line come out of the right angle?
Yes. And it's because now this problem is going to be solvable with similar triangles.
Oh,
Okay? Yes.
Do you happen to have like a paper towel or something?
I do not know. I have graph paper.
Oh my God, Jenna.
I mean, it's just water. It's fine.
No. Those are from Evan's 10th birthday party. There's like 5 of those left. Scott.
His 10th birthday party.
I don't know. I made that up.
Oh, from his review.
What?
Jenna contaminated the room.
All right.
Literally, it's on my paper.
I didn't
Yeah.
know you
Is that your
did.
drool, Jenna?
No, it's
From
my
being
water.
sick?
No.
Just wear that.
I don't know.
She's like the girl from freaking Dory. She's like,
Yeah. I also have another question. Why does it say 0 days since you thought
Why
about
am I
it?
getting
It's
this
true,
one
isn't
from?
it?
No, it actually
just
saw
thought
it
about
up
a duck,
yesterday.
didn't you?
Yeah, but it's 0 days since you've thought about a duck.
It is.
You
You're
definitely
thinking
just
about
thought
a
about
I
duck.
also
Yeah.
just did.
I'm so
You have to
lost.
think about
It's
a duck.
0 days.
Right.
okay, Jenna doesn't
I
get
know
silly
all about
jokes.
it.
So.
I know people that
She's having a blonde moment, it's okay.
Hey, no. I understand. It's because another way to write that is 0 days since you haven't thought about a duck.
What?
Right?
That was
You what,
kind of-
buddy?
They both kind of mean the same thing, though. All right, here we go. So, just with this information about right angles, we're going to prove these triangles similar. Now, we don't have any information about the sides, so we're not going to use these guys. We're going to use double angle. So check it out. Let's try proving the small and the large similar. Right? Does everybody see all 3 triangles? 1, 2, and 3?
I feel like we angle for all of them.
Angle's the most useful. You're going to use it 90% of the time.
Is it the same though, for, like all the others too? Like it acts the same.
We use
way?
SAS for one of them. We did. It's okay. All right, so we're going to prove the small triangle similar to the big one. Again, not congruent because they're different triangles, but like we're going to prove that they're similar. And we need 2 matching angles to do so. So right now, you can see I have a right angle in the small triangle. I also have a right angle in the big triangle. So we already got 1 angle matching. Good job, everyone. All right, next thing we're going to do.
I didn't do anything.
Wait.
I don't see any vertical angles, right? Small right triangle, big right triangle. That's what we're trying to get the same, okay? Forget about the medium right now. Cool? Small and large. They share 1 angle. So we're halfway there. Schlaffer?
You said they share a side too.
They do, but this side is shared between the small and the medium, not the small and the large, right? We're pretending that doesn't exist for now when we're looking at the large triangle.
Where's the where? Can you identify the small, medium, large?
Small,
Yes.
medium,
Ah.
large.
Oh.
Yeah. Yes.
Did you already say that they all share the same angle?
Not yet, but we're going to. So check it out. Kozovic already noticed that, look, see how angle B is used by the small triangle?
Yeah.
Isn't it also used by the big triangle?
Yes.
So now we have
2
2
angles.
blue angles and 2 right angles that are shared. So we have angle. So I'm going to write down by shared angle, angle B is congruent to angle B. Silly to say, but yeah. Both triangles have the same angle. That's what we're saying right there. Now, we already were given that those are right angles, so now I've got the 2 angles. I've got the ones they gave me and the ones I mentioned, right? So now I can say by angle similarity. Now, Jenna, you do need the squiggle.
Okay.
Okay, so we know it's not talking about like congruency or something, right?
Yeah.
And now I know those 2 triangles are similar. So I'm going to write that triangle. Let's do the small one first. Remember the big letters are the points. So we've got B, C, and D here. I'm going to call it triangle BCD. I like to keep it alphabetical when I can.
CBD.
So that's BCD. The big triangle. So now here we got to match them up. So brace yourself, okay? We're going to match up B from the small triangle to to the letters in the large triangle. I'm going to do S and L just so you can see. All right.
That's a great job.
It used to be. B is blue. On the big triangle, what else is the blue angle?
No, B.
B. They share it, right? The big triangle and the small triangle share blue B, right? So they're going to be the same. Angle C on the small triangle. Yes, Jenna?
Why don't you put S and L in the triangle over again?
Small and large, so you know which ones I'm talking
Oh,
about.
yeah, yeah.
You don't have to, but I'm just doing this so you
Okay.
can see. Good question. All right, so C is our next letter. It's this unknown angle down here, right? It's not the right angle, right? It's just this much of it from here to here. You with me on that? Okay, it's the unknown angle. It's not the right angle, it's not the blue angle. So look at the big triangle. It's not the right angle, it's not the blue angle. What must it be? Angle A, right? So it turns out those two angles are congruent. We'll talk about that later, but right now, C and A go together, okay? Does everybody see how I got that? Right angle, blue angle, leftover angle, right? So C, the leftover angle, must be the leftover angle here. Right angle, blue angle, leftover angle. Cool. D, thanks for being honest. D, right angle, right? What's the right angle in the big triangle? C. Right? The big triangle.
Yes.
Are we good? Okay. What we're going to do is going to take a little bit of work and a little bit of writing, but it's the same thing I just did. We're just doing it for all the triangles, okay? Cool. All right. So we matched up small and large. Let's do medium and large now. So look at the medium and look at the large. What angle do they share?
Hey.
A. So angle A, whatever it is going to be the same for both. So I'm going to color that in.
Wow.
See how they both share it?
Yes.
Right? This guy has a green angle, and then this guy uses the green angle as well. So we're going to say by shared angle.
Oh, this is not.
What?
Wait, oh, never mind. I know the next step.
Angle A congruent to angle A. Now, if you notice, doesn't the medium triangle have a right angle and a green angle?
Yep.
Yeah.
Doesn't the big triangle have a right angle and a green angle?
Yep.
Yeah.
So by angle, they're similar. Wow! You're being a great audience.
You're welcome.
I'll be here all week.
Couldn't you also say that the big and the small triangles share angle C?
Ooh, why did I do that?
Kind of, but not really. The big and the small triangle don't share it. See how it's called C, but it's not the whole angle, right? And it uses all of C.
She's dying.
Okay? See how these share A because it is all of A, both of them, right? Same thing with B for the small and the big. Right? Okay. So, medium and large are going to be similar. I'm going to use CSP, so I need to make sure I write their letters. Medium triangle is ACD. Again, I'm going to keep it alphabetical when I can. And the large triangle, how it compares to it. Okay, here we go. A in the medium is green. Right? A is green. What's green in the big one? Also A, right? It's the shared angle. C in the medium one is this unknown angle down here. Only this much of it, right? So it's going to be the unknown angle in the big triangle. Well, wait a minute. That angle is not green and it's not a right angle. So I go to my big triangle. It's not green. It's not the right angle. What must it be? It's B. So it turns out that's blue. We'll prove that in a second. So it turns out C goes with B. Are we cool with that?
Oh, we're doing
Not green, not right. It's this guy, right? Not green, not right. It must be that guy. D in the medium triangle is the right angle. What's the right angle in the big triangle? C. Here's what we're going to do now, because I know you guys are like, come on, why can't we do this? We found out that these two are blue just now, right? That's because B and C go together. B on the large triangle is that. C on the medium triangle is this. So by CSP, they're the same, right? So I'll say by CSP, angle B is congruent. I can't call it C. What should I call it?
D. C.
D, C, A.
D. Oh, BCA.
DCA. Right?
What do you mean D?
Cool. I did that by CSP. Notice how C and B go together, right? I can also by CSP get the other one. So I'll say by CSP. Let's use like I don't use that.
Buzz language.
All right, look up here.
Yes.
Green, so A on the medium triangle should go with what on the small triangle, or on the big triangle. We proved earlier that these two are both green, right? So you've got A and C going together. A and C. The large triangle uses A for green, and the small triangle must use C. Do we see how those line up? So we said that earlier. I'm just going back and getting it. By CSP, angle BCD is congruent to angle A. All right.
Wait.
So,
Wait, so how do you explain that angle A is shared between the medium and the large?
angle A.
Yeah.
So if I go to medium and large, right?
Okay. They're together.
Yep, see it,
But
they are
you have
together.
up there that angle A equals angle A, so I was like really confused as to why you put that.
So I said, so by shared angle, the medium triangle and the large triangle share angle A, right?
Okay, so angle A.
They're congruent, right? And therefore I've got two angles now, green and a right angle, green and a right angle.
Okay.
Cool?
Yeah.
Good question, Caleb.
I have a question.
Yes.
Since you use CSP 2 times in a row, do you have to do 2 steps, or can you just say?
Nope, you can say by CSP and get both. That's fine.
All right.
That's fine. I understand that. So now we've done small and large and medium and large. What two do I need to link up?
Small, medium.
Small. Nope, I already have small, medium. Oh wait, small, medium. Yeah, I need to do small, medium. Hold on. I think I did this backwards in different class. Small, medium. All right. So look at the small triangle. It's got red. It's for a right angle. Blue and green. Does the medium also have red, blue, and green?
Yes.
Yes.
Yes, so by triple angle, right, we overachieve. These triangles are going to be similar. So we're going to say by, angle, angle, similarity. We know the small triangle, similar to the medium triangle. Let's name them. Small triangle we called BCD earlier, so I'll call it BCD now. Let's match up the parts. B on the small triangle is the blue angle, right? What's the blue angle on the medium triangle? C. Right? C. So I wrote C. C on the small triangle, well that's this guy, the green angle, right? Goes with what on the medium triangle?
Which one?
On the medium? A. We're talking small and medium now. The two easy to see ones. D on the small triangle is the right angle. What's the right angle on the medium triangle?
B.
Try again.
CDA.
CDA, yep, I'm going to call it D here. Obviously, I couldn't call it D if I was going to talk about it, but to match my letters, all I can use is one, right? Did you get that? Okay, good. I know it's a weird thing, but okay. It's the best if you don't think about it. All right, so there we go. We've got those guys. So now I'm interested in their sides. So Jenna, instead of saying they're congruent, the sides, because they're not, right, we have to say they're related to each other. I'm going to show you how we do that. The angle's congruent, right, we've been doing that. That's fine. Here's what we're going to do. By CSP.
Whoa.
It's the same thing as we've been using, okay? With the angles, I'm going to do it with the sides now. But remember, sides are not congruent in similar triangles. They are proportional. So this is what this means, Jenna. By CSP, back up here. BC and BA go together, right? So I'm going to write BC relates to BA. We do it by division. And I'll show you why that is. Jenna, if I were to relate 3 to 6, if I were to relate 3 to 6, I could do 3 over 6. If I were to relate 4 and 8, I could do 4 over 8. If I were to relate 5 and 10, I do 5 over 10. Now notice, all those reduce to what? Half. So it describes their relationship. Does that make sense? So that's why division describes their relationship, right? When you write them in division, it tells you, oh, that's half. Okay? That's why division's relationships. It's a ratio. So, BC and BA are related. Do I know if they're half, triple, or quadruple? I have no idea. But I know they're related, okay? And I know that CD would be related to what, Jenna? CD is going to go with what? Very good. Now, the one that everybody forgets about is the first and third. So, BD is going to go with what? What's BD going to go with?
BC?
BC. Now, I'm going to do that for all my triangles. So first, I found all my triangles to get them similar. Now I'm going to write down all the sides for all my triangles, okay? So, here I go. This one, again by CCP. I'm going to do a little thing here so I can keep it organized. AC must go with what? I'll give you time to write it down at the end. AC goes with what?
AB.
AB. CD goes with
BC.
BC. And AD goes with AC. All right, write them down.
So are you saying the ones on top are the same to each other, or they're equal to the ones that are on the bottom? No,
These go together, and these go together, but not across. Remember, we can't mix and match.
so BC go. I don't know.
Okay? I got this from that, right? Right? This gave me that. We're not going to cross these, okay? They're their own thing. And then I'm going to get from this the same thing. Okay? So now let's write this one down. BC must go with what? I'm here.
CA.
I'll let you write it down after I'm done. CA. And CD must go with
AD.
AD. And BD, again, first and third over here is going to go with
CD.
CD over here. I'll let you write it down. All right. Cool. So that's how their sides relate.
Oh my god.
It's a lot of writing. But
Not good.
what we did was not hard, right? We just took the letters and wrote them all down.
I think the right is hard.
Okay,
Oh.
I get like what you're doing on this side of the line,
Yeah.
and I get what you're doing on this side of the line, but I don't think that I could do it by myself.
I know.
don't.
That's why the quiz is Thursday. Sorry, it's not up there anymore. Quiz is Thursday next week. We have plenty of time. Okay.
Whoa, what's that,
I was
Similarity?
gonna say like
These are
Don't
not
worry about it.
Thursday is I don't want to.
I want to know what one.
I know. I'm not expecting you to get a problem like this and just know how to go through this. I'm not. That's not what I'm expecting. Okay? Yes.
How does like somebody like think of like
I know, right?
like how does somebody like just have that in their mind like, oh, I need to do this in order
All
to
so what they
I
did.
wish
So
they
what
would
they
have
did
that.
is they were playing around with triangles and they messed around with stuff and they found something really cool.
So they just thought, let me just put BC
They
over
just
BA
played with the
right
math.
now.
These the Islamic people too.
Who's
No.
they? I'm gonna go back and
Well, for this it was Pythagoras, although Pythagoras probably didn't exist. Yeah. Jenna.
Did I miss anything else?
No. Basically all that stuff. Okay? That's all we've been doing all week.
The same thing.
Okay. So, and we started with more basic stuff, Jenna. This is kind of in deep, okay? We started with just this half. And it was with two triangles. So we stopped after that. Okay? I'm sorry.
It's okay.
Alright? So, I proved all the triangles similar, then I matched up all their sides. Is everybody okay with that? The idea of that? Could you do it on your own? I know. I'm not expecting you to. Okay? Do you see where I got the stuff? Okay. I need you back. So here we go. The next thing I'm going to do. They're talking about little letters. I'm talking about big letters. So I'm going to switch out all these big letters for their little letters. Check out how B, C, shut up and look. B, C is the same as A, right?
Yeah.
So I'm going to take all my big letters and switch them out for the little guys. So you watch. You can write it down after I'm done, but I want you to see where I'm getting this from. I can't show you it all at once unless I want to make the letters really small. So BC, look on your diagram. What is BC on your diagram? You can't see my hand. It's little a, right? BC is little a. What's BA on your diagram?
Badass.
That's right.
Wait, C?
Oh.
It's C. It's also F plus E, but we'll write C, okay? What's CD? Oh, we don't have a letter for that. Let's give it a letter. How about G?
See your triangle.
Hey, G.
Let's call it a G. I know you can't see mine. Look at your own.
No?
Fix your collar.
I wrote a G.
Oh.
No.
Road.
Yeah, why not? Let's call it G.
Ah.
I'm not fixing it.
What is CD on your diagram? Don't look at mine. Oh, we already did. What's AC?
What's wrong with my
Little b. BD on your diagram. F. BC. A. All right, let's just pause. I'm going to do that for all of these, okay? Do you see how I got them?
No.
BC is A. So where I saw BC, I wrote an A. I'm rewriting this part. And you didn't see it because you're too busy talking while I was doing it.
Who, me?
Yeah, you.
Oh, I'm sorry.
No, it's
It
okay.
was my fault.
It's okay. I'm not mad. I just want you to realize like there's a way you could fix that.
I thought you were
Right?
telling me I was talking.
Yeah,
No.
stop.
Not you.
Matt, I'm gonna use the restroom.
No. And again, I'm not mad when I say so. That's fine.
Alright.
I just want you to
Say
realize
no to
like
me.
that would be the easiest way to fix that. right?
No.
So BC is A. If you look, BC is a little A.
Oh, okay.
Right? You see what I'm saying? I just replaced these guys with their little letter equivalents, okay? Why am I doing that? Because I want little letters.
So
right?
where's
Stand up that you can't see.
F was
It's
this,
over.
it's BD.
Oh, there it is.
Yep, cool. Right?
It makes me mad.
So let's just look at this for a second. What do you notice about this?
What'd you say?
What do you notice about this stuff?
That's big to large. Small to
Yeah,
large.
that's what we got, right? We went from large to small, right?
You have all the things you need.
Not yet.
You go.
We have A, B, and C. That's true. What do you notice, Jenna?
Well, I'm just asking a question. Is the F, it's F over A, right?
Mm-hmm.
Okay, because for some reason, like, that looked like a Q to me.
No, F and A.
Like, okay, thanks.
Yes.
AC and then FA are technically.
Where'd this man get G from?
Yep, these would be the same, yep.
His diagram, that line is G.
That doesn't mean A equals F or C equals A though, right? It could be like 2/3 versus like 4/6. You see what I'm saying? Right, they're the same when you reduce them, right?
So do we need FA then?
We do.
Oh.
All right, what do you notice? What else do you notice? Come on, don't be afraid.
I don't know.
I don't know.
Give me stuff. Tell me stuff that's true.
CBA.
CBA at the bottom, sure.
Oh, I think
What
I
else?
noticed something.
What?
I don't know if this is stupid, but AGF is
Oh, it's a
that's a
triangle.
triangle.
AGF is a triangle, that's true.
Is that relevant?
It's not, but again, a lot of the stuff that we're going to get through is going to be true but not useful. Again, I used this analogy the other day. It is true that turtles can breathe out of their butts, but it's not going to help us with this, right? But just because it's true doesn't mean it's helpful, right? So it's okay. Tell me true stuff, and I'll tell you whether it's helpful or not. Eventually, we'll get to know what's going to be useful and what isn't. Yeah.
Turtles really do
A and
that,
A.
though.
We have two A's.
That'd be weird.
Yay.
What if I cut out the middle, right? If I can do that, right? If that's equal to that, that's equal to that, right? Transitive property, right? So I can ignore that if I want.
Yeah.
This says divide by A. If I wanted to move that, how would I undo divide by A? I multiply by A. And when we multiply over to this side by A, multiplication's done at the top. What's A times A? A
2.
squared.
A2.
What?
A squared.
A squared
A
plus
squared,
F squared
oh.
equals.
If I multiply by A to both sides, right? I multiply A over here. A times A is A squared. So I've got A squared over C equals F, because that's gone now, right?
Yeah.
How do I get rid of divides by C?
Times.
Therefore, A squared equals C times F.
A squared.
Do you see how I got there?
C times, yeah.
A squared, C times F. I times by A to both sides. I got rid of the A over here, left me with F. I got A squared here. I times by C, it is, right? But again, cross multiplication works, but only when we have equal signs between stuff, okay? Which is very rare. It's going to happen a lot in geometry, but any other time it's not. So don't memorize that. Think algebra. How do I get rid of divides by A? Times by A. How do I get rid of divides by C? Times by C. Okay? And I'm here now. You smell them stepping.
I guess.
This is useful. You see why I know this is useful? Because it gets me something I'm interested in.
They're hiking shoes.
I'm going to do the same thing for the middle one.
Wow.
Okay?
Whatever. It's in the past.
You look at your diagram. What is AC in your diagram? Big A, big C.
BC. No, AC. What?
Little b.
Ew.
What is AB? Sorry, what is AB in your diagram?
How?
AB is C.
AB.
What is big CD in your diagram?
C, D,
G.
G.
Oh, I get it.
What is big BC in your diagram?
A.
B, what's my straight name?
What is big AD in your diagram?
E.
C or E.
Guys, so I
E.
having a race to get
Yeah,
this
I
one.
can see that.
What is big AC in your diagram?
B.
Little b. All right, what do you notice? I know. Little b.
We don't have
I
to
feel
go
like
to
90% of rap names are invented in geometry.
Dude, it's Lil Tree.
Little tree died.
Equals C. I mean, C
Go
times
D.
G.
Nice.
Check it out. We have two b's. So yeah, guess what? I multiply b over to here and c over there, and I get b squared
B squared
equals c times e.
E.
All right, I could do that with the bottom as well, right? I did it with the first two, right? I could do that here as well, but I already have what I want. I got a squared and b squared. Now, I can add those together, right? I'm allowed to do that. I can add numbers together. Here's two numbers, 2 and 5. Can you add them together? Sure, why not?
7.
Here's two numbers, add them together, right? Here, I'm going to do that. A squared plus b squared. Now, I can't tell you what it equals. I can't just be like, it equals what I want. No, you can't do that. But you can add them together. We know what a squared and b squared are equal. We're not going to say c squared because we don't know that yet, right? What is a squared equal? What is a squared equal?
C.
C times f. I'm going to wrap it in parentheses, not because I have to, but because I plugged it in for a squared, okay? Then I'm going to add what b squared is. What is b squared? C times e.
Oh, look at it. There's your thing.
All right, hold on. I'm going to write this, and I'm going to tell you why it's true in a second, because it's easier to see it backwards than it is forwards.
Quit it. You told me you weren't going to get sick.
I'm not sick.
All right, here we go.
Is that F?
Right.
Here's why this is true. Again, it's easier to see backwards than it is forwards. If I were to give you this, wouldn't you distribute the c?
Yeah.
And what would you get? C times f
And C times
plus c times e.
That's the same thing.
How?
It's the same thing, right? So I think you guys are good at distribution, right? I think you know about distribution, right? C times f plus c times e is what we get, right? The reverse of that is pulling out, okay? Which is a valid strategy. So if you were to pull c out from both, it becomes just the one c, okay? You pulled c out from both, and what's left over is this. And I can prove that because going backwards, I get the same thing. Are we cool with that? Okay? Now, this looks great, except we've got c times f plus e, and I really want c squared. What is f plus e?
Like the Undertaker.
What is f
C.
plus e?
E.
What is f plus e?
And then I get
It's c.
my grandma's cars.
Wow.
So, if f plus e is c, can I write this as
Yeah. Rock balls. But she's at work. She'll come here. And then we'll go.
This is so much.
Is that Boo! I'm sorry.
when you graduate from this class,
I'm gonna
you will become
cry.
a god.
I will not be a god because I'll
So
forget
wait,
it.
I already
in
am a
2 seconds,
god.
'cause I'm good at that.
Yeah, you
Mr. Mack, are we turning this in after class?
Jenna's back and she's got attitude. What?
I got
Are we
new
turning
bigger
this in
attitude.
after this or no?
No.
All right.
Leave that up there. Leave that
I will.
Whoa.
I'm gonna go back over it again, right?
Jenna's
right.
cat.
How
Can I?
C times c is c
It's
squared.
gonna die.
I thought it was F.
F plus e. If you look at your diagram,
What did I kill?
what is f plus e?
Did we do everything? No.
Oh.
It's c. It was c the whole time, right?
And because it's lowercase, that means that it goes by the side.
Yeah. So lowercase means the length of it, right? Whereas uppercase means like the point. Does that make sense?
Yeah, so that means that AD, whatever's up there, would not equal C because they're uppercase.
Yeah.
Okay.
Yeah, you probably know. You
All right. Here's what we did. Here's what we did. Here's what we did.
don't remember it.
We did 3 things. It was a lot of writing, but we really just did 3 things. So here it is. Okay. We did 3 things. We proved all the triangles similar.
Yeah.
Double A, right? Then we used CSP since they're similar. We can say their sides are similar, right? Then we took those and replaced it with the stuff, and we moved things around. And we won. That's all we did. It was a lot of writing, but that's all we did. So if you wanted to be like, man, I have to do this on a quiz, right? If I said, look, you're going to have to prove the PFAC, I'll give you the diagram, right? Which I will. Don't go, oh my God. No. We have 4 things. Get the triangle similar. Oh yeah, that'd probably be a good thing to do on a similarity test. And then after they're similar, use CSP. That'd probably be a good thing to do on a test that has to do with similarity, right? And then replace the stuff so you can talk about little letters, right? And move stuff around.
Imagine this final.
And you know how to move stuff around.
I have a question.
2 days.
I have a question.
Yeah, we are gonna be here.
It's gotta be
I went
less
to
than
fly.
like 10 problems.
Please put your tongue back in your mouth.
We got some time.
I have a question.
Yeah.
You're gonna get sick.
To figure out A squared, you have to figure out what,
The
like how to
dirtiest part,
solve,
right there.
how to solve A.
That is.
And then we can figure out like how, like
Well, it is a
figure out how to prove
sport
A, and
model.
then we
That
have to
point
prove
one
B.
might
And
get
then square those, that's how you get C.
Right.
And prove how C is.
Sick.
How A is A and B is B.
I need a tissue. Can I go back?
Kind of. Yeah. I think, I might not be understanding you.
Yeah.
Like if someone's like,
I have those.
For now it is. Okay.
I'm like,
All right. Guys, so how did someone come up with this, right? Pythagoras probably didn't exist, right? But there was a cult of Pythagoras, and much like most cult leaders, they are figments.
I need to die.
Someone was playing around with similar triangles, and they got this, and they realized, oh, 2 A's, 2 B's, right? And they set it up, and this happened, right? Now, there's lots of ways to prove Pythag. There's ways to do it with shapes and moving stuff around. What this means is that if you were to draw a square off this side, it'd be a squared, right? Draw a square off this side, it would be b squared. And if you put those together, they'd add up to the square that is c squared here. So you can move the shapes and actually put them together. That's another way to do it. Yeah.
Okay, I don't mean this in like any
That's okay,
bad
please
way
go ahead,
as
please go ahead.
possible.
Mhm.
But okay, I get like learning this is supposed to like benefit us.
When
but,
are we
like,
ever gonna
what
use it?
do you do in your future that you like wish
Exactly,
you
right.
used?
Okay, so I do not believe that school should be in charge of teaching you how to do your jobs, right? And because I don't think we can. The jobs you're going to have 10 years from now might not even exist today.
That's right.
And so the real big brain teacher moment is, oh, we got to teach them for the future, so we'll do our best. No, that's bullshit. Here's what we're going to do. Here's what we're going to do. We're going to teach you how to learn. That way when the new job comes up, you can learn it. So when I present this stuff to you, I don't care if you know geometry. What I'm really doing is I'm using geometry to teach you how to learn and how to think. Because this is a problem that requires a brain.
I hate my brain.
And it's not something you're naturally good at.
Dude, I ain't got no brain.
And that's the type of thing you're going to have to learn in the future, is how to be good at things you're not naturally good at. I could teach that with anything. I could teach language, I could teach music, I used to. But I'm using math because that's just what I'm here to teach, right? I don't care if you don't know how to do this a year from now. I want you to know how to think yourself out of a situation. That's what I'm doing. I'm not going to BS you and say you're going to use this in your future, because it is BS. Okay? Have I told you this story about Scott Chaputis?
Yeah.
I have, right?
You called me him.
Yes. Okay, so Scott Chaputis, I think it was during finals when we were here super late. So Scott Chaputis was sitting in my Algebra 2 class with old Miss Fraley. Old Miss Fraley used to be a model, she would say. She would go up on the board.
Chippendale.
Very Norwegian. Don't blow my story. So, Scott Chaputis, the pen flipper, right? Really all relaxed all the time. Just a cool looking dude, right? He goes, when am I ever going to use this, Miss Fraley? Miss Fraley, Scott, of course you'll use this in your future life. Of course you will, right? And she was very, very proper. And Scott said, no, I won't. And she said, Scott, what are you going to be when you grow up? And you know what Scott said? Chippendale.
Yeah, I didn't know
I
you
know
were
that.
And Miss Fraley blushed and cried, and class was over.
So
You might not use this. It's okay. That's not the point. I'm not here to teach you how to do your job. If your job wants you to learn something, they should pay for it. Right?
They should pay me.
what happens when the simulation
Why
is
are we
over?
paying for you to go do a job for a private company? This is a public school. We teach you how to be better citizens, better teenagers. That's our job.
Is this relevant to us when we die?
Can you please watch this?
No?
Why not?
Is it me?
Careful, please just watch this.
No, I'm good.
Why not? It's hilarious.
Does it have
Why are
to
you
be
yelling
me?
at me?
Because
This is funny. Watch it.
Oh my fucking god.
Watch
That?
it!
Yes.
Watch it!
You know what, Schlaffer?
I'm on a nice one.
The music makes it. That's like the Lee Bowling kid, right? She's in the swing and then she's, yeah, it's just like that, but way more violent. It's not a problem.
Wait,
All right.
what did I miss out on?